The last lesson had to do with learning relationships among angles and how to name angles. In today's lesson, we're going to be talking about special angle pairs. Our first pair of angles are called complementary angles. Complementary angles are two angles whose sum of their measure is 90 degrees. So if I were to take angle 1 and angle 2. Angle 1 and angle 2. By using angle addition, I can show that the measure of angle 1 plus the measure of angle 2 would be equal to 90 degrees. Therefore, I would say angle 1 and angle 2 are complementary angles. I could also have an angle that might have a measure of 30 degrees well, maybe it doesn't want to be 30 degrees. We'll make it 20 degrees and another angle of 70 degrees. If I take the measure of those two angles, 20 degrees plus 70 degrees, add them together, I get 90 degrees. Therefore, those two angles would be what we would call a pair of complementary angles. The key is they are only two angles. Not 5, not 6, it can only be two angles. Our next pair of angles, based on the sum of their measures, are called supplementary angles. Supplementary angles are a pair of angles, so two angles, whose sum of their measure is 180 degrees. So let's say we have angle 3 and we have angle 4. If I were to add the measure of angle 3 plus the measure of angle 4, it would equal 180 degrees, and that's by using angle addition postulate. If you remember, this would be a straight angle, so I know the measure of that angle would be 180 degrees. Supplementary angles. I could also have an obtuse angle, let's say of 110 degrees, and an acute angle of 70 degrees. 70 degrees, maybe. 70 degrees. So if I take, I can't get a 70-degree angle to look good here. So 70 degrees. And if I would take the 110-degree angle, add to it the 70-degree angle, that would equal 180 degrees. So I would say that those angles are supplementary. Sometimes it's hard to maybe know which goes with 90, which goes with 180, and I'm a word associated person as well. So a lot of times I'll tell students, think of the C on complementary. So C for complementary. If I draw that little bar, it looks like a 9, so 90 degrees. S for supplementary. If I draw that, it looks like an 80, so 180 degrees. These are the two angles that are special based on the sum of their measures. And once again, remember, it's only a pair of angles, so only two angles. Our next special pairs of angles are based on how they are positioned in a plane. Our first pair of adjacents based on of angles based on their position in the plane are adjacent angles. And for angles to be adjacent angles, one of three things have to occur. They have to have what we call a common vertex. So they have to share a vertex. If I could spell common. This just means they have to share a vertex. So a common vertex. They also have to have a common side. So a common vertex, they have to have a common side. And they cannot share, so they have no common interior points. So they can't share any interior points. And I will never ask you to give me a definition. The important thing is being able to look at a diagram and recognize these angles. So common vertex, common side, no common interior points. Angle 1 and angle 2 would be called adjacent angles. They share this common vertex right here. They do share a common side. Their common side would be this ray. And none of the interior points of angle 2 happen to be interior points of angle 1. I say adjacent angles live next door to each other, and that common side is the fence that separates their backyards. There is one special pair of adjacent angles. These would also be a pair of adjacent angles. So angle, I never can make a 3. Angle 3 and angle 4 would also be adjacent angles. But because their sides, these uncommon sides, form a line, these are called a linear pair. A linear pair of angles. They're a special pair of adjacent angles. Linear pair. And there is something special about the relationship between linear pairs of angles. We say that linear pairs of angles, so this is that postulate, linear pairs of angles linear pair of angles is supplementary. A linear pair of angles is supplementary. And we just talked about how supplementary means that if I add the measures together, the sum is 180 degrees. So it will always, if they're a linear pair, that sum will always be 180 degrees because a linear pair of angles is supplementary, which makes sense because if you look, they form a line. They're linear, a line. I'm having a hard time writing here right about now. They're supplementary. So a linear pair of angles. Again, linear pairs of angles are next door neighbors. Our final special pair of angles are called vertical angles. Vertical angles are angles whose sides form opposite rays. And we know when we have opposite rays, that opposite rays form a line. So that suggests to us that in order to have vertical angles, then you're going to have two lines that intersect. Oops. Excuse me. So you have to have two intersecting lines in order to get vertical angles. If you do not have intersecting lines, you will not have vertical angles. Vertical angles, I say, live across from each other. For example, angle 1 and angle 2 would be a pair of vertical angles. Angle 3 and angle 4 would be the other pair of vertical angles. And there is a special relationship between vertical angles. The postulate that we'll use with vertical angles will say that vertical angles are congruent. Vertical angles are congruent. And we know if vertical angles are congruent, that also means that their measures are going to be equal. So when I look at this diagram, angle 1 is going to be congruent to angle 2, whereas angle 3 would be congruent to angle 4. So these are our special pairs of angles that we will be working with in tomorrow's lesson. Two pair having to do with the sum of their measures, and the other three having to do with their position in the plane.